Okay.
So, Dora asked me to tell you a story about writing using rules. And like any story, I have a morale, so I will tell you the morale beforehand, so it's easy. I think that visualization-driven development is undervalued, and you should try it more. And in this instance, we had our domain experts that needed to steer the process, and we needed a short feedback loop, including our domain expert, and we steered on value and risks. So the story begins. The story begins always somewhere, and in our case, the story begins with a company that builds products, metal products for the medical environment. So you should think about a table for an MRI scanner, a table that moves very smoothly into that scanner. So that's it's complicated to build with a lot of components, and some other parts were complicated to build in the sense that it had a lot of instructions to build. And they had an old COBOL system, and that old COBOL system, the original programmer died, and he found a new one to maintain it, and he had a heart attack 3 years ago. So they decided we should go with something newer, something that is more up to date and more maintainable, since it's critical for their production. So they went looking, and they said, well, what could we do? We could build a custom. They did custom build, and now I see my sheet fitting. Oh well. And they could buy an existing tool, but an existing tool of an ERP system still needs implementation. And in both cases, they needed the migration of the old data. And actually, the custom builds, they asked us already to make an assessment what would it cost, and they decided to use existing software and ask us for the migration. So in both cases, we needed to parse COBOL, and we wanted a quick win, so we only wanted to parse an island. We didn't use Petit Parser because we didn't know it well enough, and because we had a lot of islands. And we started by structuring the source. So we said we have a COBOL file, and in a COBOL file there are a lot of imports, and we focus on the number of lines of code. And when we did the visualization, we actually found out that we were missing a type, namely missing. Some files were simply not there. And at first, a lot of files were missing, and they said, oh well, maybe we have some other code as well, so we got a lot more code. And then we still had some files missing, and here you see a bit of the picture we presented about the size of their whole system. And each box represents a COBOL file, and the color blocks inside those blocks are the references. And when it's white, it's a reference to a small file, and when it's dark gray, it's a reference to a very large file, and when it's red, it's a reference to a missing file. So,
Could have been worse.
Yeah, it could have been worse, and they said, well, we learned island parsing works because we got what we wanted, and we also learned that we missed some files. And our user said, well, yes, and this is also some standard ERP product, and we're not using everything that the old ERP system could. So I don't think this is a problem with missing files, but it's something we need to keep in mind. Okay. So we went further and into building trust that we could really extract the thing. So our first browser was just of one data file, and here you can see the data file is shown because we anticipated it would be more. We had the data file, all data files loaded, it's a bogus column because it's not filled. And then, of course, you also have the rows in that file, and yeah, when you select either a column or a row, you could see the details of that row, or in this case, of the column, showing the values that are in that column. Well, doing conversion, a data conversion, we follow the standard ETL process. We start by extracting from the old system, then we focus on how do we transform the thing, and then we focus on loading it into our new system. So we started by extracting, and important to keep in mind during data conversion is that not all data is needed. Do you need to extract? Because yeah, some data is simply not needed, and other data is simply there are only a few values, so it's too costly to automate extracting them. You can better do them over by hand. So you should focus on what has value to extract. And let's say it's about the same thing. You should also parse as little as possible. And we only needed to parse the data definitions. And parsing COBOL, you have to keep in mind that there's no standard COBOL. In that sense, it's like Smalltalk. There are a lot of dialects. And in that time, they didn't have standard libraries for exporting data or reading data or something like that. So all COBOL data will probably be structured differently. And actually, the COBOL data definitions are polymorph. So you can say, okay, in this file, things are defined this way, but well, you can interpret them also this way. And maybe in some other case, you can also interpret them this way. So you can have multiple data definitions for the same files and for the same records, actually. But luckily, the source we encountered was pretty clean and had a consistent style. So this is what our model was of the COBOL files. We had a COBOL file with a lot of imports. Some of those imports were data file definitions. And in the data file definition, we found the data definition itself and a reference to the data file. Actually, the reference to the data file wasn't in the same file. It was in a file named like it. But who cares? And one of the trouble we ran into is that Pharo is only 32 bits, and we really could have used 64 bits, even when it would have been slower than 32 bits, because going from memory is a lot faster than going to disk. And we needed now to decide up front what data to import, which is making decisions without being informed what is it, without knowing what to do. So we needed to implement an incremental load, and actually our image crashed several times because we tried to load too much. So that was a bit of a hurdle. And well, the actual extraction is that we really interpreted it, and we only interpreted the entities that were needed, and we let our domain experts decide, what entity is next. And in the meantime, we also allow them to browse both the raw data and the parsed data as much as possible. And the result was a browser that allowed them to select their files and say, okay, I want these columns and I want them to be exported to these files. The export was, hindsight, not really necessary, but it was a good thing for building trust that I really knew, okay, I can extract the data, I can import it in any way I want, and so it was a good point to go further. One of sales item which had a version, and it was coupled to a purchase item in some cases. And as you can see, purchase item doesn't have a version, so was some convention about how the numbers were, and that didn't match very always exactly. So there was some work needed there. And to a sales item, there was a work instruction, and a work instruction needed materials, and the material is referred back to this purchase item. So you have the loop of when building something, you need some you have some beforehand to build something else. You say that this is a recursive definition of how to build a sales item. And actually, they coupled a sales item to the purchase item because the system itself, the old system, couldn't handle that recursiveness. So they had to buy an item from themselves in order to continue the loop, so to say. And here you see the milestone we made to visualize that work instruction. You can see the recursiveness with the arrows, that you can see the input materials you need, also some details of it, and the operations that were there. And you can see that our operations were hierarchical as well. And we also showed the original data that was retrieved from the old COBOL system. So the second part is the transformation, and there are actually three transformations you have to do. You have to check the data, whether it is correct, whether it's not good. We had a lot of work instructions that were missing materials, that had missing operations, so you can't transform them to a new structure. They first need to be corrected. So that's the second step. And the third step is that in the new structure you sometimes have fields that did not exist beforehand and are a calculation of one or more fields of the old structure. And also you have to keep in mind that doing transformations you have several ways of doing them. You can automate them, of course, but sometimes automation isn't really paying off. It's easier to do manual transformations. And that can be either done in the old system by simply saying, okay, well, we detected that item wasn't correct, fix it. Or you can correct the data one step further in the extraction, in the tool we were building. And we actually built a preliminary UI and a C-side UI to enable that. And you can load and correct the data directly from a separate source into the ETL tool, and you can correct the data in the new system. And based on the impact, you should make a choice. Because when it is some key field you want to correct, you shouldn't do it in the new system, because then all connections are failing. But when it is some text that didn't really fit and needs to be checked anyway, the new system is probably the place to be, to name an example. And to show and transform the structure is really the core of the load process. So this is to show what we needed to do, more or less. On the left side you see the old structure, and on the new side you see, well, we had an item. It could be, and we had to mark isn't bought, but isn't sold either. It's only made in order to be incorporated in another product. And you can see here that the operation, it was actually renamed because in the new system operation was something you would do on a machine. And there we really had to build the process out of sub-steps. So we had to reform the hierarchy. So building load, we started on focusing on the key entities to reduce risk, and later you change your shift into, okay, now we really want to test it, and we use the order we're going to load it into the new ERP system. And during the load, you had to iterate back to the extract because you found out you didn't have all data, or you needed more data to extract. And of course, also more transformations were needed. And finally, going live. There was a decision made about going live. We had some restrictions because of the production downtime when they were moving data from the old system to the new system. Production had to be down. And also there were some restrictions because of the financial year. The ETL team also was responsible for spitting out the reports for that. And when you were halfway, then the reports, of course, would probably be funky. So the original idea was to go live in January 2012, but actually we did it in the Easter holiday in April.
Does it work?
Hmm?
Does it work on the Easter?
Yes, it worked. It worked. A bit more hours needed than expected, but on the other hand, availability of key users are always only when the deadline approaches. Then the key users are available enough to really make the last decisions. So we went with the big bang because of the constraints, and so we needed trust into that the conversion would really go. And there was a test environment running since January, so it's 3 months. And the test environment was incrementally loaded during the process. At least that's what I thought, and later on I learned that it was only in end of March that they started doing it. Okay, lessons learned. Visualization development really works. Our key users could make the decisions they needed to make really fast. And there were, good decisions we could really use. They were informed decisions. And there was some delays, 3 months, but it was clear from the way we developed that it was clear to both sides that it was on their end because they didn't make the decisions, or they didn't have time to make the decisions in time. And the feedback loop should all parties. There was actually a party we forgot to include, and that was the supplier of the system. start exporting that data. But it really doesn't say, yeah, you don't have one, you have to become the expert of both systems.
I wanted to ask about you mentioned that you were written that the file is subject to Git and you were needed more to handle this side of data. Kind of just wonder. I mean, if you go back, this is a really old system, and so they managed to handle that amount of data and the very old machine. So, I mean, is it how it is different today? I mean, why today you need like multiple orders of magnitude memory for handling the same data which were produced years ago, and why it is so critical that you need everything loaded into the memory and
Well, when you start to extract, you want to be able to read everything, more or less. And especially in our case, well, you had the old system, but we didn't have access. Yet they actually sent us the compiled version of the old system. We didn't put in the efforts to get it running, and besides, it would be still, you don't know the old system, you don't know the UI, so it's very hard reading the data using the old system. So reading the data, we wanted to look into the data files, and the data files were binaries. So there wasn't any tool that allowed us to just look into the data files. And some data files were relevant and some were not. So what we actually wanted to do is say, okay, of all data entities we have, just put it